cancelable system call, basically means that if a child thread is waiting on that call, and someone else is saying, okay, thread number blah blah blah, go ahead and cancel yourself, the thread has no choice but to cancel. Okay, so are we okay so far with the sample program? Other than the little syntax problems that I had to fix to get it to work. No questions? Okay. The rest of this, explains pretty much the same thing. Now, what is interesting is ernum. Do you guys still remember ernum? A little bit. Ernum is not shared by the threads. Global variables are shared by all the threads. The heap is shared by all the threads, but not ernum. Okay. The reason is ernum is actually a pretense of a global variable. It is really not a global variable. It is a macro that will expand to the dereferencing of a pointer returned by a subroutine call. Okay. In other words, there's a subroutine call that returns a pointer to an integer, and ernum is a macro that wraps around that call to dereference the pointer returned by a call. That call turns out to be thread safe. In other words, one ernum is allocated to each thread of a process. So that is really nice, because if you have any type of file operation error, each thread can take its own time to print out or to process ernum without any worry that the other P threads of the same process will mess up ernum because they also encounter errors. Is that making any sense so far? Because if you just look at this example here, okay, the main thread can try to perform some IO, operations here, and that operation has a problem, and therefore ernum is set at this point. But at the same time, the child process can perform another I/O operation that is completely independent to the one that the main thread has executed, and it also encounters a problem, which also sets ernum to a different value. So in this case, if these two ernums are the same thing, then they will just interfere with each other, because ernum in this case will no longer be thread safe. But because ernum is not like that, it's really not a global variable. Instead, there's one instance of ernum per thread. Then these two threads have no problems, because this process can take its time and interpret ernum all the way down here, and this process, this thread can also take its time and interpret the ernum of this particular thread much later on. Okay, but the whole point of this is ernum is not a real global variable. It's not allocated statically. It is a macro wrapping around a function, and the function returns a pointer to an integer. So that's why it behaves kind of like a global variable, but it really is not. Okay. Any questions at this point about ernum? I have a question. So how come we don't use a function call instead of ernum and use it as a global variable? Can anyone guess?
Wouldn't you just get wiped by a different thread? If there's two threads executing synchronously, wouldn't the second thread had an error, it would override error?
Not if you make it a thread safe system call. There are thread safe calls and non-thread safe calls. It is all historical, because P threads came along way after ernum has been widely used in programs. So many programs and a lot of existing code already used ernum as a quote unquote global variable to report an error associated with a previous I/O operation or system call. And to maintain backward compatibility, they had to create the illusion of ernum when P threads come along, so that a lot of the existing code will still continue to work. Yep.
If you read the pthreads man page, it's specified by the POSIX specifications that ernum is thread specific. So
yeah, but that's how it is thread specific. But ernum, exists way before P threads came along.
How do you assign to ernum?
Hmm?
Can you still assign to ernum in some way? I mean, you can't.
Can you update ernum?
Yeah. How do you change it?
Well, the function returns a pointer to an address, so you still have a left value. You can still change it if you want.
Okay.
In fact, if you really want to know how ernum is expanded, you can say, ernum macro definition. These are all the error messages. You can also just look at the source code of ernum.h and find out exactly how it is expanded. It's a little bit beyond the scope of this class, but we'll go ahead and do it anyway. It's probably just going to include another header file from here. You just have to track it down. It's including bit slash ernum here. So we'll just take a look at that one too. Bits ernum.h. Okay, so here we have ernum location to be defined as a pointer to an integer. This part here is out of my expertise of C. I know this part, this is basically additional attributes associated with. Okay, this means that this is a subroutine. Okay, I know that much. So ernum ernum location void is the prototype of a subroutine that returns the pointer to an integer. The rest of it basically are additional specifications, to control, to basically specify, special attributes of this subroutine. Yep.
Throw just means that it can throw exceptions if you're in C++.
Okay, and then the underscore const means
Those compiler specific.
they are compiler specific, yes.
Yeah.
But I don't remember exactly what this one means. I'm pretty sure if you look it up, you can find it in GCC's manual. Okay, but the important part is, go ahead.
Errno.h says that L value is assignable,
Yes.
no matter what it's required to be.
Yep, but the definition of ernum is right here. Pound define ernum to be the dereference of the return value of ernum underscore location. In other words, it's doing exactly what I said it would do. You have a function that returns a pointer to an integer, and then ernum is by itself defined to be the dereference version of that address. So that's why it can appear on the right hand side as an integer. It can also appear on the left hand side as something that you can assign to. Yep. That was
Since it's got value in const, that means that you can't modify Errno.
I don't know whether that's the case or not, because if that is the case, I think you can put the const on this side.
Yeah, but that's a GNU attribute, I believe, and that's what it's saying the same things if you had a const in front.
Okay.
That doesn't mean you just can't modify the address?
I don't think so. I believe it's actually the
Well,
data
the
behind it.
address is returned by the subroutine. So the address is not, it's already returned by a subroutine.
Well,
It
let's
is the
try
question.
Errno equals 5. See what happens.
See whether the compiler barks.